All right, today we're going to talk about the most fundamental rules of our reality.
And I'm not talking about suggestions or, guidelines.
No, these are deep, unbreakable laws that govern everything, every star, every flame, and every single heartbeat.
And among all these rules, none are stranger or more powerful
Then the laws of thermodynamics. Yeah, those laws. The ones that decide why time itself flows forward, why energy spreads out, and why ultimately everything seems to fall apart.
Look, these aren't just some rules for physicists in a lab. They are the deep programming, the code that writes the beginning, the middle, and the very end of our cosmos.
Okay, so what are these cosmic laws really? You hear the term and it sounds super intimidating, but despite their massive implications, the basic idea isn't as complicated as you might think.
At its heart, thermodynamics is just the study of energy. That's it. It's about how energy moves, how it transforms, and maybe most importantly, how it kind of slips out of our control. It explains why a car engine works, why stars shine, and on a way simpler level, why your morning coffee always gets cold. If you can get a handle on these laws, you're starting to understand the ultimate limits of what's even possible in our universe.
Okay, let's start with the basics. There's actually a zeroth law. Yeah, they added it later, which is basically just the rule that makes thermometers work. Super simple. But the first law, now that's probably the most famous one. It's all about conservation.
So, the first law tells us something you've probably heard before. Energy can't be created or destroyed. It just changes form. And this is a perfect example, right? You've got chemical energy locked away in fuel, you burn it, that becomes heat energy. That heat creates motion, say, in an engine, and that motion can then be used to generate electricity. The energy is just switching hats, changing its costume, but the total amount of it stays exactly the same, always.
But, and this is a huge but, while the amount of energy never changes, its usefulness sure does. And that little detail is where things get really, really strange.
This brings us to the big one, the second law. This is the rule that governs decay, disorder, and even the direction of time itself. And it all boils down to one powerful concept: entropy.
Now, you've probably heard entropy described as just chaos or disorder, but that's not quite the full picture. It's really about probability. Think of it this way. Entropy is a measure of how many different ways energy can be arranged. And the universe, well, it has a favorite direction. It always moves toward the state that has more possibilities, the most likely outcome.
And this is just a perfect everyday example. You can stir cream into coffee, right? Easy. The two mix together. But have you ever seen the cream just unstir itself, go back to being a separate blob? Of course not. Or a broken glass. Have you ever seen the pieces jump back together and fly into your hand? No way. Why? Because there are a billion ways for the glass to be broken, but only one way for it to be whole. The universe always moves towards the state with more options, towards higher entropy. It's a one-way street.
And this isn't some abstract, far-off idea. You see its effects everywhere. It's the reason your room gets messy all by itself, but you have to put in energy to clean it up. It's why stars burn out. It's why every single engine, no matter how efficient, wastes some energy as heat. It is the universe's slow, unstoppable march towards a more uniform, more spread out state.
Okay, so if entropy is this unbreakable, one-way street, that leads to a really deep question. Could this be the secret engine that's actually driving time forward? I mean, think about it. This is a huge question. Most other laws of physics, like gravity, they don't care about the direction of time. They'd work just fine if you ran the movie backward. So why do we only experience it in one direction? Why can we remember the past, but we can't remember the future?
The answer, amazingly, is the second law. The reason time feels like it has a direction, what scientists call the arrow of time, is because our universe is constantly moving from a more ordered past to a more disordered future. Our memories are basically just records of that lower entropy past. So in a very real way, the unstoppable increase of entropy is what we experience as the flow of time.
All right, so we get the direction of things now. But what about the limits? What happens when you push these laws to their absolute logical extremes?
This is where the third law comes in. It defines an ultimate limit, absolute zero. That's zero on the Kelvin scale. It's the coldest temperature possible, a state where all the jiggling of atoms would just stop. But here's the crazy part of the law. You can get really, really close to it, but you can never actually get there. Reaching absolute zero is impossible. It's like the universe has this finish line you can see, but can never, ever cross.
And that brings us to the final, really big question. If the second law is true, if entropy is always increasing, what happens at the very end? What's the logical conclusion to this story? What happens when everything is spread out as much as it possibly can?
Well, first, the universe reaches a state of perfect balance. No more hot spots, no more cold spots. Everything, everywhere, is the exact same temperature.
And if there's no difference in temperature, there's no way for energy to flow. Without that flow, you can't do any work. The energy is still there, sure, but it's useless. It's just a lukewarm, uniform bath of nothing.
Scientists have a name for this. They call it the heat death of the universe, a future where all the stars have burned out, matter has decayed, and everything has just settled. A cold, dark, perfectly quiet state of maximum entropy. No structure, no complexity, and no life. It's the final chapter, written by the second law of thermodynamics.
So, what's the big takeaway here? These laws aren't just weird because they're hard to understand. They're weird because they peel back the curtain and show us the hidden logic of reality itself. They tell us why energy flows, why things break down, and most deeply, why we even experience time as a forward-moving river. They are the silent, unbreakable rules that are shaping every single moment of our existence.